Hey guys, welcome back to the channel. Today's video is going to be all about measurements. We've got plenty of different measurements in our day-to-day life. So we've got distance, we've got time, speed, we've got weight and mass. So those two are related. They're not the same thing, but they are related. This is a physics equation. It's not technically completely maths, it's actually part of physics as well. Weight equals mass times gravity. Weight is your grams in kilograms. Mass is a slightly different thing. You don't really use mass in maths until later on in your studies, probably more towards A level. In your studies at the moment, you're probably only going to be using weight. So don't worry about the mass and the gravity thing. So obviously with measurements, you've got plenty of different units to go along with that. There's lots of different units you can use in measurements. Obviously for length, you've got meters, centimeters, miles, yards, kilometers. With maths, you've got grams, kilograms. With maths, you've got milligrams, grams, and kilograms. Volume, of course, you've got milliliters, liters, meters, cubes, centimeters cubed. There's loads of different units that we're going to be using. And I'll teach you all about those in this lesson. We're also going to be learning about unit conversions, transferring one unit to another, understanding the relationship between the units. So is this unit 100 times this unit or 1,000 times this unit? We're going to be looking at that as well. We're going to be adding different units together. So that's, for example, a question that we'll be answering in this lesson. We'll be converting between units and comparing different units as well. So it'll give you a really good understanding of all the different unit systems. We'll be going through the metric and the imperial system as well, just to give you a quick overview of what the differences are between those two. Speed, distance and time, they're all related, and we're going to be looking at the link between those two as well, and I'll show you a handy trick to work out if you've got two of them. If you've got speed and distance, for example, I'll show you how to work out time. If you've got speed and time, you can work out distance. They're all related. There's a little triangle. It's really, really useful. If you've got two, you can work out the other one. And with regards to time, we'll go through the different units. We'll go through years, leap years. We're going to look at clocks too. I've got a watch on at the moment, an analog watch. We're going to be looking at Roman numerals, how to work out and tell the time. That's going to be quite useful as well. And then lastly, we're going to be going through money as well. Now, money is something you're going to use throughout your life. It's probably one of the most important aspects of maths. It's learning how to work out money. Working out change as well. So if you've been given a £10 note and you need to give a certain amount back, then working out change is extremely useful. So that's something we're going to be going through today as well. That's a brief overview to this video. I've got blackcurrant today, but I've also got my pen and my paper. You guys get your drink, get your pen and your paper. Let's get into the maths.
Measurements. Firstly, we will talk about the relationship between speed, distance and time. So I'll go through each one individually and then we'll see how they all link together. We have speed first. So speed is the measurement of how fast an object is travelling. So cars can go up to 70 miles an hour on the road in England. So miles per hour is one of the units we've got for speed. So the units we have: miles per hour, how many miles you can travel in a certain time; kilometers per hour, another unit of speed; meters per second is also another unit of speed, so how many meters you can travel in a certain number of seconds. So speed is the measure of how fast an object is traveling. So distance is the measure of how long something is. So distance and length are essentially the same thing. The length of a ruler is 30 centimeters. It's also the distance of the ruler, one end of the ruler to another, is 30 centimeters. So it's the same thing. So distance is the measure of space between 2 points. It can be more if you want to be interesting and do sort of the distance of from here to here to here, then that would be 3 points. Or you could do as many points as you want, but it's the distance between a certain number of points. Often it is from A to B. How far is that distance? Now, what units do we have for distance? The units of distance or length: millimeters, centimeters, meters, and kilometers. You've also got things like the inch, the foot, and the yard. So those are imperial. These are metric. So the metric system is all about ones and zeros essentially. So it's every 10 is a new distance, every 100 is a new unit. So every 10 is a new unit and every 100 is a new unit. So the units for distance and length show this really well. So we've got millimeters are 1/10 of a centimetre. Centimetres are 100th of a metre. and meters are 1,000th of a kilometre. So 1,000 meters are a kilometre, 100 centimetres are a metre, 10 millimeters are a centimetre. So if you want to work out how many centimetres there are in a kilometre, between that and that, there's 1,000 times difference. So 1,000 meters make a kilometre, and 100 centimetres make a metre. So you can do 100 times 1,000, and that will give you how many centimetres are in a kilometre. 1,000 times 100, so 100,000 centimetres are in a kilometre. That's quite a lot of centimetres. So then in the metric system, you've got an inch, a foot, and a yard. You've got 12 inches in a foot, which is roughly 30 centimetres. A foot's roughly 30 centimetres. 12 inches in a foot, and 3 feet to a yard. So a yard is slightly smaller than a metre, because if a foot is 30 centimetres, 3 feet go into a yard, that's roughly 90 centimetres, so it's a little bit shorter than a metre. Time now. So time is the measurement of how long something takes. What units do we have for time? Milliseconds, seconds, minutes, hours, days, weeks, fortnights, months, years, decades, centuries, and millennia. So there are 10 milliseconds in a second. There are 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 7 days in a week, 2 weeks in a fortnight, 2 fortnights in a month, so that's 4 weeks in a month, 12 months in a year, 10 years in a decade, 10 decades in a century, so that's 100 years in a century, and 10 centuries in a millennia, so that's 1,000 years in a millennia. So it's quite a lot of units for time. With years we have a funny one. There's actually also a leap year, and a leap year has one extra day than a normal year, so there's 365 days in a year. There's 366 days in a leap year, and the reason that is because they have to adjust, because there's not exactly 365 days in a year. Every 4 years there's a leap year. It goes on every multiple of 4 from 2000, so 2000, 2004, 2008, 2012, 2016, 2020, 2024, 2028, and so on. The way that you measure time is using a clock. So when you're measuring distance, you might use a meter ruler, or you might use a tape measure. You'd measure speed, you'd find out the distance, and you'd divide it by the time that it took. With time, the way you measure it is on a clock. Now, it's important to be able to read clocks, because you've got 2 different types of clock. You've got a digital clock and an analog clock. So a digital clock will look something like this, 0830. So that's a digital clock reading. An analog clock will look something like a traditional clock, which you've seen, something like that. And it'll have the 2 hands as well, the short hand and the long hand. Both of these represent 8:30, 8 o'clock, 30 minutes around the clock, 8:30. So digital's a little bit easier to read, I'd say. But analog is more traditional, and it's very, very important to be able to read both. Because, for example, my watch, it's only got analog on it. It's not got a digital interface on it. So it's very important to be able to read these numbers here and memorize which numbers they are. Because on my clock, it doesn't actually show which number is where. So if you don't know which number's where, it'll be a guessing game as to what time it'll be. So it's very, very important to memorize that there's 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Of course, you've got a short hand and a long hand. And normally you have a second hand as well, which is quite a small one. It's quite thin and it ticks every second. My one doesn't have it, but it'll look something sort of along the lines there like that. Okay, so those are your clocks. So oftentimes on some analog clocks, you'll get what are called Roman numerals. So I'm sure you've probably heard of them before. It's very important to know what Roman numerals are. It can be very hard to tell the time if you don't know what the Roman numerals are, unless you've memorized exactly which position the numbers are in. Generally, it's best just to count 1 to the right of the top one, and you'll know that's 1, 2, 3. So if I'm on my watch, we count 1 to the right, that's going to be number 1. Then you can count along 2, 3, 4, so it's 4 o'clock now. We'll go through Roman numerals now. So these are the Roman numerals. So the Singular I is 1, 2 I's is 2, 3 I's is 3, IV is 4, and we'll see why that is next. V is 5. So V is 5, you've got 1 before 5. 1 before 5 is 4, so IV is 4. VI is 6, 1 after 5, which is 6. But this I is symbolising 1. V is 5, 1 after 5 is 6. VII, 2 after 5 is 7. 5 plus 2 is 7. 5 plus 3 is 8. IX, 1 before X, 1 before 10 is 9. X is 10, 1 before X is 9. XI similarly would be 11, XII would be 12, XIII would be 13. Then you can start adding the X and the V together to make 15. IXV would be 14 because you've got 1 before XV, which would be 15. Simply put, those are the Roman numerals there. So if you get any Roman numeral clocks, you'll know exactly what the numbers are. So now, going back to the relationship between speed, distance and time, let's get into that now. So as I said before, speed, distance and time are actually all related. You've got this funky little triangle that you can draw, and it'll always show you exactly how to work out one from the other two. As long as you've got two of speed, distance or time, so say I had speed and time, I could work out distance. If I've got speed and distance, I can work out time. Or if I've got distance and time, I can work out speed. This is what's so awesome about this triangle. So the triangle looks like this. So you've got your little triangle there with a T in the middle, speed, distance and time. So this symbol here, this little line here, is a multiplication sign. This sign here is a division sign. This line here is division. This line here is multiplication. That's all you need to remember from the triangle. So if I wanted to work out speed, the other two, distance over time. Speed equals distance over time. If I wanted to work out distance, I know that it's speed times time, which makes sense. If you're looking at the distance, it's how fast you've gone over how long you've gone for that speed for. And the same with speed. How far have you gone, how long it took you. If we want to work out time, we know distance over speed, because this is a division sign here. There we go. So these all make sense. Speed equals distance over time. How do I know that that's true? Well, if you think about the units for speed, it's miles per hour or kilometers per hour. If your distance is in kilometers and your time is in hours, that makes perfect sense. Kilometers per hour. If it's in meters and it's in seconds, meters per second. How many meters have you gone per second? This divide, the per means divide. The distance, how fast have you gone and how long have you gone that speed? That's your distance. Time, how far have you gone and how fast have you gone there? It makes sense. So that's your relationship between speed, distance and time. This triangle, you need to try and memorize that triangle if you can. It's so useful in all of your exams. In every maths lesson you've got about any speed, distance or time, that equation will pop up all the time. And it's going to be really useful if you can memorize that. So I would definitely recommend memorizing that if you can. Okay, and the last thing we're going to talk about is money. With regards to money, you've got lots of different currencies. So you've got pounds, which we use here in the UK. You've got dollars, they're predominantly used in America, but you also can use Canadian dollars. There's Australian dollars. There's plenty of different dollars, but the original dollar is America, and the euro as well. So this is where I want to get into the sort of calculations section, because it's quite important to be able to work out different change with regards to how much money you're given and how much money you need to give back. So So if I'm in a shop, for example, and I get to the counter and I give them over a £5 or a £10 note, but I've only bought £2.99's worth of goods, it's probably a good idea to know how much money I need to get back. If they give me the wrong change, or if I'm the person on the till, I need to know how much money I need to give them back. I'm paying for a chocolate bar that's only £3, and I have given them a £20 note. I need to work out quickly, I need £17 back. I've given them 20, I've taken £3 out from my chocolate bar, I need 17 back. It's very important to work out that change. It's easy when it's just pounds on its own, but when you add in pennies or cents, it becomes a little bit more annoying. So we'll have a look at it now. So if I go into a shop and buy a Coke, that cost me £1.50. So it's £1.50. And then I buy Mars bar, cost me £1. And then I buy a sandwich that cost me £3.20. Okay, so I've quickly totaled it up. How much have I bought? £1, £2, plus £3 is £5. So that's £5, 50 and 20p, that's 70p. So I've spent £5.70. So if I give the cashier a £10 note, but I've only spent £5.70, I'm going to be expecting some money back. I don't want to pay £10 for some things that are only worth £5.70. So I'm expecting some cash back. What I need to do is quickly do a subtraction. How much money have I given them? How much do I need to pay for? And see how much money I'm expecting back. £10 minus £5.70. What I like to do is count upwards. I think it's easier that way. £5.70. I need 30p to get to £6. And then to get from £6 to £10, it's going to give me £4. So I know to get from £5.70 to 6, I need 30p. £6 to £10, I need £4. So I know that my difference between 10 and £5.70, £4 and 30 pence. That's how much I'm expecting back from the cashier. Not too bad. It gets a little bit more tricky when you're adding in just penny values. So say I bought 4 sherbet straws. 4 sherbet straws at 1p each. That's 4 pennies. 4 sherbet straws at 1p each, it's 4 pennies. I buy a Freddo bar, it costs me 89p. I then go and buy a can of Coke and it costs me 58 pence. Now I know for a fact that's definitely under £5. So if I'm going to give them £5 cash, I know I'm going to be owed some money back. So what I'm going to do is I'm going to quickly do some mental maths and figure out how much I've spent. 58p plus 89p plus 4 pence. This is where we can use our long addition because I don't really want to try and do it in my head because it's going to be a little bit harder. So I'll quickly note this down. If you practice your long addition over and over and over again, you will be able to do this in your head, but for practice sake, I'll do a quick long addition on this side, making very sure to keep in my columns, making sure that I know the difference between my pennies and my pounds. If I had any pounds in here, they have to go in this column because a pound is 100 pennies. This is my units pennies, my tens pennies. My pounds would go here, but I don't have any at the moment. 4 plus 9 plus 8 is 21. Put my 1 down there. My 2 in the next column. 8 plus 2 is 10, plus 5 is 5, and then 1 in this column, in our pounds column. The total of my goods is £1.51. If I'm giving them a £5 note, I need to know the difference between my £5 that I'm giving them and my £1.51 which I've taken. So the difference between those, what I'm going to do is I'm going to do my trick before where I'm counting up from £1.51. So I know to get from 51 to 100 or to a pound is 49. So I need 49p to get from 51, from £1.51 to £2, and £3 to get from £2 to £5. So I'm going to add my £3 to get from 2 to 5, and my 49p from £1.51 to £2. So it's going to be £3 and 49 pence. So I hope that made sense, guys. I hope you enjoyed the video. Please let me know if you had any problems at all. Put them in the comments below. Please like and subscribe and share the video if you enjoyed it, or if we've got any friends that need any help, please share it with them and let them know about the channel. Thank you so much, guys. Have a great day. See you in the next video. Cheers.